Hello, welcome to episode 2 of the How to Make Grow a Garden in Roblox series. This episode, we're going to be making a plant placing system and making them grow. I'm going to fix something that was messed up in the last video. It's not really that bad of a bug, it's just more of a just to be safe thing. So you're going to go into the plot handover module, and right here you're going to go if not plot handover dot available plots then, and you're just gonna paste that in there. Now what we are going to do is work on the planting system. So first thing we're going to do is make some plants and seed models. I'm just gonna make a simple carrot. Now, what I'm going to do is take this carrot and I'm going to anchor all the parts. Anchor all of these, put a value inside of it. It's an int value. I'm going to call this stage. In this case, this is the fully grown stage. And let's say I want 3 stages to my carrot. Now I'm going to duplicate this model. Actually, I'm going to name this 3, just because. Now, I'm going to duplicate this, and I'm going to make stage 2. I'm just going to shorten these a bit, and that'll be my stage 2. So now I change this value on stage, I change it to 2. Now, I'm going to put these, I'm going to make a folder in replicated storage, and I'm going to name this plants, and I'm going to put these in here, and inside of here I'm going to put carrot. I'm going to put a folder named carrot, and inside of that folder I'm putting another folder that I'm going to name normal. This is so we're set up for mutations in the future. Now inside of this carrot folder I'm going to put a module script and I'm going to name it config. This is where our settings will be. So in config, in this table, we are going to add all of the settings we need. So the grow time. What's the grow time going to be? In my case, I'm going to set the grow time to 20 seconds. So we have the display name. So like when you hover your mouse over it, which is going to be a future episode, when you hover the mouse over it, you can see the growing percentage and what plant it is. That's going to be the name that's going to be displayed there. So we're going to say display name equals carrot. And now there's 3 more we need. Circle size. That little circle when you click and place your plant, and it has that little circle at first where you planted the seed. We're gonna make a size for that. That way you can change it for different plants. So circle size equals vector3.new. And for mine, I'm going to go with 0.05. So this number right here is how tall it is. I don't recommend changing that. Just kind of looks weird. I'm gonna go with 1.5 and 1.5. Min scale. So this is the minimum scale. So I'm gonna put it as 0.65. So that's the minimum size basically. But that's multiplied by the size you actually made of the carrot. So yeah, the max scale, I'm going to put it as 1.1. That's it for the config for now, for this episode. And now I'm going to make a module inside of our modules folder. Actually, we need a new modules folder. You're going to put it in server storage. I'm going to put a folder, name it modules, just like the other one, except since this one's in server storage, this is only accessible by the server, not the client, because we don't need these ones on the client. I'm going to add a module script and name it plant handler. And like always, I'm going to name all of this in here plant handler as well. Now, inside of this module, the first thing we're going to add is the replicated storage service. Put that right up here. We'll go replicated storage equals game get service replicated storage. Then local modules equals replicated storage dot modules. And local plot handler equals require modules dot plot handler. Actually, I'm going to move this. You can just select it and Control X to cut it, and Control V to paste it down here. I'm just going to put it underneath because that's how I like mine set up. And then above that, between that and this other table, I'm going to do local plants equals this. Actually, it's going to be a little bit different. I'm going to do plant handler dot plants. And you can do this, you can make it uppercase or lowercase. I'm going to do uppercase. You can name it whatever you want. It just has to be consistent throughout the script. Now, the first function we're going to make is the plant seed function. So if we start typing down here, function plant handler dot plant seed player. We need the player, we need the seed name, and the position. Once we get all of those, we have to make another thing. We're gonna go out here into the viewport. I'm gonna add a cylinder. Just gonna scale it down. It doesn't really matter since you're going to set the size in the script, but you want to cover it however you want it to be covered. This is gonna be the circle that you get when you plant a seed. I'm going to add the stud material to it because that's how it is in the real game. And I'm going to try to get a good cover for it. I'm just gonna change the cover myself. There we go. Now, you name this plant circle. Actually, seed circle. Then in replicated storage, actually not replicated storage, in server storage, we're going to make a folder and name this templates. And inside of that folder, we're going to add the seed circle. Now in plant handler, we need to get local server storage equals game get service server storage. Then down here, I'm gonna type in local templates equals server storage dot templates. Now, what we are going to do is we're going to, I like it better as plant circle. I'm gonna rename it and say local circle equals templates, find first child, plant circle. The next thing we're going to do is get the player's plot, and then we're going to find the folder of the plant. So we will be adding seeds in a little bit. First, we're just getting some functions set up. So now I'm going to say local plot equals plot handler, not get plot, player. Then local plant folder equals, you know what, I'm gonna make a variable up here, and I'm actually going to move these up here. Now local plants equals replicated storage, find first child, plants. Now plants, plant folder equals plants, find first child, seed name, not in quotes. And now we're going to get the config. So local plant config equals require, it's a modular script, so we have to require it. Plant folder, go and find first child config. Really important this name matches the name in the folder, which in my case is config. Make sure this is not in the normal folder. This needs to be in the plant folder. And when we have mutations, we're going to have another folder and name it like gold or something. I am going to say if circle and plot and plant folder and plant config, then. This seems like a lot, but this is just making sure that we have all of those. Next, I'm going to basically make a variable for the C-frame of the circle. So local circle CF, which is C-frame, equals C-frame.new position. Just making the position vector 3 into a C-frame. Then we're going to say times with the asterisk C-frame.angles 0, 0, math.rad. This converts degrees to radians. 90. What we need to do next is create the circle. So local new circle equals circle clone. That's not clone. Clone. New circle dot parent equals plot find first child. You know what? I forgot to anchor this. I'm going to anchor this and turn off can collide. Do not turn off can query. We need that. Don't turn off can query on this or on the other plants. You can turn off some of the can collide parts in the plants if you'd like, but it's whatever you want to do. Plot first, find first child. You know what? In the plots, we need to add a new folder called plants, which I somehow added already. So just add a new folder, name it plants, and then here back in this script, we're gonna say plot find first child plants. So that's the setting its parent to that, so it's in the folder. New circle pivot to circle CF. And new circle dot size equals plant config dot circle size. So I've set it in here. Make sure this matches this, otherwise it won't work. Next, we are going to make some overlap parameters, which we will use for detecting if it is touching something. In the real game, if you place one and it is touching another like plant or circle, it doesn't really matter as long as you click on the actual ground. You can make it like that if you'd like, but if you'd like it to not be able to collide with the other circles, it won't stop it from colliding with the plants. It won't stop that. I can show you how to stop that, but it might feel a little weird when you're trying to plant it because you're going to not be able to plant it in some spots just because a plant will grow there. So right now I'm just going to make it so you can't actually collide with other circles, or you can't place a circle in a circle. Local params equals overlap params dot new params dot filter type equals enum dot raycast filter type dot include params dot filter descendant instances equals, you're going to put it in curly braces, plot find first child plants. Then we're going to get the touching parts. So local touching parts equals game dot workspace get parts in part. New circle if touching parts, then for underscore comma part in touching parts do if part is not equal, so the little squiggly line, the tilde, and then the equals, to new circle, then we will destroy the new circle. So new circle destroy, and we're going to break the loop so that we're done with that. That should be it for that. Now you cannot place it if it would collide with another one. We should be good to write the next function. But first, I'm going to write a function to actually place down the circle, because I figure it'll be fun to see it actually be placed down. And then we can make the plants grow, which is quite a big function. So first thing we're going to do is a new local script. Here, I would save the game. Save the game for sure. Then put a new local script inside of starter player, then starter character scripts. Insert a vocal script. I'm just going to call this placement client. Call it whatever you like. First, we are going to make a tool, a seed. So for my carrot seed, I'm just going to take one of these parts, these models from the carrot. Let's take this first one because it has the least amount of parts. Press F to zoom into it, by the way. So now I have my seed made, and drag it out of the model. And I'm just going to name it seed. And then I'm going to add a tool. Right now we're just going to use tools. And I'm going to name it what I want the player to see. And since there's only one part, I'm just going to call this handle so that it's what the player is holding. Then inside of this, I'm going to put a string value and name it seed name. In this value, I'm going to put carrot you want to input whatever this folder is named into this value. Make sure it's a string value. Right there, caret. Now you're going to put this into the starter pack for now. We should. Oh, I forgot to unanchor it. You want to make sure none of these are anchored. If you have multiple parts in your seed, you have to weld them together. Weld them all to handle. Make sure this is named handle, just like this. At least one of the parts is the one that you want the player to hold. Now I'm going to unanchor it. Now if we play, I can hold it, but nothing happens yet. In this placement client script that we made, local user input service equals game get service user input service equal replicated storage equals game get service replicated storage. The modules folder, and we need plot handover like with every other script so far. Local modules equals replicated storage dot modules. Local plot handover equals require modules dot plot handover. Now we need another folder in replicated storage. We name this one events. Inside of this, we're going to insert a remote event. I'm going to name this plant. I'm going to name it plant seed. And then back in the placement client, I'm going to go local events equals replicated storage dot events, and local plant event equals events dot plant seed. Local player equals game get service players dot local player. Local character equals player dot character or player dot character added wait. Local camera equals game dot workspace dot current camera. Now we are going to write a function. Local function get mouse position in 3D space. Now, inside of this function, we're going to detect where the mouse is on the screen and what it is on, because the mouse is 2D. It doesn't actually have depth. It doesn't actually go onto anything. So we need to do a raycast, which basically just puts like a laser off of it to see what it's like hovering over. So local plot equals plot handover get plot player. Local blacklist. So this is just going to be things that we don't care if the ray hits. It needs to go through them. Like if it hits our character, we don't want it to detect it. We want it to go straight through it. Local blacklist equals this here. We're going to go character plot find first child plants. So it'll ignore all the plants in the game. Now we're going to make a raycast. First we need to get the mouse position. Local mouse position equals user input service on get mouse location. Local mouse ray equals camera viewport point to ray mouse position x mouse position dot x mouse position dot y. We're not going to put a direction because we don't care how far it goes. This is just to get the origin point of the mouse. Then we're going to make parameters. So ray params equals raycast params dot new ray params dot filter type equals enum dot raycast filter type dot exclude ray params dot filter descendants instances equals blacklist. Next we are going to get the raycast result. Local ray result equal game dot workspace colon raycast. The origin is going to be mouse array dot origin. The direction will be mouse array dot direction, and parameters will be ray params. Oh, I forgot. You have to do mouse array dot direction times with the asterisk. 100 is just how many studs, so like you can change that to whatever number you want. That's how far away they can be, or the camera can be, while you can still place stuff. So now return ray result. We're going to detect when the player does an input, so user input service input began connecting a function. The input right here is the type of input and it's game process event. is if they're clicking a button or if they're clicking inside the chat box. So we don't want that to trigger this. So if GPE, then return end. If input dot user input type equals enum dot user input type dot mouse button 1, then that means they left clicked. If they left clicked, we want to see if they're holding a seed. So in this right now, we're going to detect when they're holding a tool. So if character find first child, which is a tool, then go plot equals plot handler dot get plot player, then local mouse ray equals get mouse position at 3D space. If mouse ray and mouse ray dot instance dot parent dot name equals plant area, because in the plots we made the dirt plant area, so this means you can only plant it on the dirt. Then we will and mouse array is descendant of plot. Now that means that they are clicking on the dirt in their plot, which means we want to plant the seed there. So we're going to get the position, local mouse position equals mouse array dot position, and we are going to get the seed name, which remember we put that value in there. The seed name, local seed name equals character find first child, which is a tool, find first child seed name dot value. And now we're just going to fire the event. So that plant event colon fire server, and we're going to send it the mouse position and the seed name. Now we have to go onto the server. So I'm going to make a new script in server script service, and I'm just going to name it server for now. And inside of this, I'm going to get replicated storage, and server storage, I'm going to get the events, and up here I'm going to get local server modules equals server storage dot modules local. We haven't written one yet, so I'm going to just go to the event part. Local plant event equals events dot plant seed plant event dot on server event connect function. Now we didn't give it the player, but it automatically receives the player. So now we have the player, and then we passed it the position and the seed name. So now we have those three things. With those three things, we're going to get the player's character, we're going to get the seed tool, and we're going to actually pass through the instance as well. So we're going back to placement client, and right here I'm going to pass through mousearray.instance just to double check on the server so they can't place stuff on other people's plots if they hack. So now this right here is instance. Local character equals player dot character, local seed tool equals character find first child, which is a tool. If seed tool find first child seed name dot value equals seed name, then that means that we have the same seed that the client is saying we have, because they could fire this event with hacks without actually even being they don't even have to be holding the seed, and they could do it with some sort of really overpowered thing. So we're just double checking on the server, because the server really can't be tricked like that. Local plot equals, we're going to get other modules, local modules equals replicated storage modules, local plot handler equals require modules.plotHandover. Plot equals plotHandover.getPlot player. Now we're gonna right here we're going to say and if plot if instance is descendant of plot. So now we're just don't put the if there. And so now we're detecting if they actually have the seed and if it's actually their plot. Now we have that plant seed function, right? So I'm going to get the plant handler, local plant handler equals require server modules.plant handler. And now we just plant handler that plant seed. And what did we need? We needed the player, we needed the seed name, and we needed the position. Now we should be able to test this. I have a typo here. If you see right there, in this script, I missed an S. This has to be master array.instance, because this is the actual part. So is descendant of plot. Oh, sorry, that needs to be that instance. Do not capitalize the I. It will mess it up. And now it should be working, but it's not. I wonder why. I'm going to do a debug thing. We're going to print circle has been created, because this is after we create it. So if this prints, that means it was created. So I'm going to test that. It was created. Is it stuck in the ground? Circle has been created. So it's creating the circle. I believe it's deleting it immediately. I think this touching parts thing is not working properly. So I'm going to print touching parts. So now I'm printing the actual table, which is touching parts. Part. What is part? So that is a little concerning. I believe that is just this dirt. It shouldn't be detecting that though. Did I forget to? I forgot to put the parameters. Look, you gotta put the parameters in here so that see, new circle params. Now it should work. There we go. See it? We got the circle. Stud texture makes it blend in a little. I'm gonna make it a bit bigger. So I'm going to go into the config, and I'm just gonna make it 2.5 by 2.5. And now it's a bit bigger. And if you look, you can't place it inside of other ones. This video is already running really long, so I'm gonna have to end it here, but episode 3 will be making the plants grow, and that should be coming out tomorrow. Thanks for watching.